begins with the process of filtration. Fluid and small solutes are forced under pressure to flow from the glomerulus into the capsular space of the glomerular capsule. Now click the tubule to see the second process. As this filtrate passes through the tubules, specific substances are reabsorbed back into the blood of the peritubular capillaries. Now click the peritubular capillaries to see the third process. In addition, some solutes are removed from the blood of the peritubular capillaries and secreted by the tubular cells into the filtrate to fine-tune the composition of the blood. The rest of this topic covers filtration, while the filtrate processing topics in this module will cover reabsorption and secretion. Click the glomerulus, tubule, or peritubular capillaries to revisit any of these processes. A coffee maker provides an everyday example of filtration. The paper filter acts as the filtration membrane. It holds back the large coffee grounds while letting water and small solutes like caffeine and flavor molecules pass through. A force is required to drive this process. In a coffee maker, it's the force of gravity. What force would you guess drives filtration in the glomerulus? Select the correct answer by clicking the appropriate box.
Sure.
Yes, blood pressure is an important variable in the effective filtration of the blood. Just as a filter keeps grounds out of your coffee, the glomerular filtration membrane keeps blood cells and proteins out of the urine passageways. This filtration membrane is composed of 3 layers: fenestrated glomerular endothelium, basement membrane, and the many filtration slits formed by pedicels of the podocytes. Passage through the filtration membrane is limited not only on the basis of size, but also by electrical properties. Now click the filtration membrane to see an animation of glomerular filtration. Glomerular filtration is a process of bulk flow driven by the hydrostatic pressure of the blood. As you can see, small molecules pass rapidly through the filtration membrane, while large proteins and blood cells are kept out of the capsular space. You can probably guess the severe effect on blood and urine composition if the filtration membrane is damaged or destroyed. The fluid and solutes collecting in the capsular space is called glomerular filtrate. Now click the pipette to take a sample of the glomerular filtrate and see what it contains. Now click the Analyze Filtrate button to determine the contents of this sample. Our sample from a healthy person shows the common components of filtrate to be water, ions such as sodium, potassium, and chloride, nitrogenous wastes such as urea, uric acid, and creatinine, and useful organic molecules, including glucose and amino acids. The concentration of each of these substances in the glomerular filtrate is similar to its concentration in plasma. How might the contents of the filtrate be altered if the filtration membrane is damaged or destroyed? More than one answer may be correct.
Okay. Which one?